Welcome everyone to Singularity University's Global Summit. I'm your host, Kevin Edwards, along with Don Pickering, the CEO of Olis Robotics. Don, thanks for being with us.
Yeah, thank you.
What brings you to the Global Summit?
So we were actually asked to exhibit here. I got contacted by the leadership of Singularity, and I think they're looking for companies that have foundational technologies that are impactful to sort of solving hard problems for the planet. And I think our company certainly qualifies for that.
Well, what are some of the hard problems for the planet, and how are you working with them?
So we build software for teleoperated robots, and robots in factory environments work very well because they're working on the same problem over and over again. But there's a large need for robots in underwater operations, for offshore energy, to space exploration, and satellite servicing, maintenance, to environmental cleanup, nuclear decommissioning, and robots to date that are really underserved in helping to solve those problems. And it turns out that software is really what's lagging, what's needed to overcome those types of challenges.
Well, let's help people conceptualize what that might look like. So what am I dealing with when you mean remote robotic control?
So when you're running a robot outside of a factory, and it could be surgery or ROVs, remotely operated vehicles used for underwater, you really have to have the pilot be connected to the robot right now, and they use video, which is two-dimensional. And so being in close proximity and using only video provides you with a very limited perspective on what you're working on. So they're quite crude in operation and tend to be inefficient and also accident and error prone. So what we're doing is providing the ability to use real-time 3D information and begin to use sensors and algorithms to provide a software layer that operates much like a brain. So we can do real-time 3D mapping of where the robot's working. We have machine learning software that detects and differentiates objects inside that model.
Oh, wow.
And then we begin to use that technology and those sensors and algorithms to provide really the safety and efficiency of factory robots, but in real world environments. So it's the goal, and really what we're delivering is better than human perception and dexterity, but delivered at any distance.
Well, I'd have to think that would save a lot of companies time and a lot of pilots' time who might not be as efficient as, say, a robotics person who deals with this instrument every single day. Whereas if I'm a pilot, I guess the example would be like, if I try to play like a video game, I'd have no idea how to use it. But if I gave it to my 12-year-old cousin, he'd be a wizard at it. Is that kind of a similar concept?
I mean, it is similar. We actually, it's funny, we delivered the first Xbox controller capabilities for underwater robots. And we noticed that certainly younger pilots take to it very, very quickly. But it does simplify and speed up the ability to do work, but it also creates a safety layer that just isn't there. So right now, when they're doing critical operations underwater, for example, these are $5 million robots that cost $100,000 to operate. So if they're performing a critical task, they drop a second robot in the water to get a side view or top view and make sure that they're grabbing things correctly. And every time they do that, it's a $200,000 to $300,000 charge. So by providing software that gives them real-time 3D perspective, much like a CAD model, you can rotate around virtually what you're grabbing on, make sure you have a perfect grasp. So every time they're using our software, they'll save $200,000 to $300,000 when they're performing critical operations. And for that might be millions of dollars a year per robot, and there's 1,500 robots currently deployed. So it's a big cost savings, but also a lot provides a layer of safety that's just not there right now in robotic operations.
Are any operations that you're working with have lives on the line or anything like that?
So right now we're focused on subsea, so they're not really lives on the line. Okay. Sorry, I take that back. Our company was actually started to solve a problem for the Navy. The Navy's been mandated to clean up all of the test ranges with the bombs and ordnance that are on the seafloor.
Oh, wow.
And globally, this is a major problem. There's 200 million pounds of unexploded bombs on the seafloor. And so they use divers to do that remediation and do that work. And so with this technology, The reason why our company was started was to provide enough dexterity and awareness with robots that they could take that work over from pilots or from divers, which is far safer, and also allows that work to be done at any depth. And so in that case, we're with divers, it's very dangerous. They do get killed, doing that work, and providing the ability and allowing for robots to take over that work is a real game changer, and that goes beyond those test ranges and those bombs. Just 30 miles off the coast here, there's 50,000 barrels of low-level nuclear waste off the Farallon Islands that people just assume could never be picked up. And with this software, we can actually now operate robots at depths but have them handle things delicately so that we can actually clean up things that we never thought we could reach or address before.
Interesting. So when you're just saying you're going to go meet with some VCs, when you were meeting with VCs, what are some of the concerns they have for you, or some of the questions that they ask you?
I think a lot of it has to do with just that there's a changing paradigm in robotics where the legacy of robots was to build everything for a single robot. And so you have all these proprietary systems and controlling them. And it costs a lot of money when you're building everything one-off. So the old model was to spend $30 million for prototype one of a robot that has a very limited use window. And so with our software, what we've built is essentially the first high-level operating system, sort of like what Windows did for DOS, we're providing for the robotics world. And it's a bit of a change of perspective to have software be the driver, right? And then ultimately, we believe that software and algorithms and providing a uniform control environment will really, I think, change how robots are adopted and used. Rather than having master's level engineers spend days just to train a robot to do a single exercise, we can provide software that allows you to do that in real time.
I had someone explain to me, it's like trying to figure out robotics is just a robot trying to figure out unpredictability. How are you managing this? Is there new innovations that are coming in that you're excited about? What are your thoughts on that?
Yeah, so I think there's a lot of people in the robotics world that are just gunning for autonomy. And the problem with autonomy is that when it fails, it has complete mission failure. And that's why we don't see robots in the real world yet. I think ultimately there's not that safety and that predictable operations and dynamic and changing environments. So I think ultimately providing a framework where we can begin to evolve how humans and robots work together is really needed. There's some critical problems that need to be addressed right now. Decommissioning nuclear power plants, hazmat, and chemical spill response and cleanup. Robots can and should be doing that work, but we need the software and the technology to enable that. And so one of the things our software provides for is really now a transition from the manual operation of robots to the using data and algorithms to assist pilots for safer operations, to where we can begin to hang algorithms to automate routine responses to routine objects for the first time. And so much like driverless cars started with cruise control. It's primitive task assistance. And then from cruise control to dynamic cruise control, or park assist to where it parks your car for you. So it's a progressive path of pushing more capabilities to the machine as you safely and confidently can do that. And what we're providing for the first time is for the robots to have that progressive capability to achieve autonomy. And we think, our thesis is that is the path to autonomy. It's a staged process that is done safely, but progressively over time.
Right, done safely, because a lot of people are nervous about AI and robots taking over, and all these theories that enforcement faces. What advice or what feedback would you give to someone who might be a little scared by the future of robotics?
Yeah, well, I think I think it's certainly something to be aware of. I think like anything with emergent technologies, we need to think about the context and the ethics for their use.
Right.
From my perspective and our company's perspective, I've mandated that we only build technology that helps the environment or that helps human lives, and so there's a lot of work that can be done even within the energy and the defense spectrum that is consistent with that, right? So I think that's something that's quite a ways off, and I think that there's to not embrace this technology when this is really about doing things that can't be done by people. It's taking robots to places where humans can't or shouldn't be. 4,000, 5,000 feet underwater, on the moon or in space or in orbit, or in nuclear environments for cleanup and remediation. And those aren't scary sort of aspects at all. I think those are very positive aspects for humanity.
Don, I really appreciate your time coming on the show today. You set the vision, taking robots where humans can't go.
Yeah.
You also talked about the decision making behind that. What do we think about ethically and morally for these robots? It takes a lot of leadership, especially in a position like yours. So the last question I have for you is, how would you define a real leader?
Well, that's a good question. I think a leader is somebody that has a strong moral fabric and foundation for their work. And so when I think about this company is sort of manifested from my intention to think about how I can best impact to scale positive impact and change for the world. And my commitment to that and my the resolution I have to make that happen has manifested this technology in this company. And I think ultimately leadership is about maintaining that commitment to the core values that we hold and to create communities and companies and technologies that are consistent with those values.
Don, well said. Thanks for sharing that with us. For Don Pickering of Olis Robotics, I'm Kevin Edwards telling you all to keep it real.